Do you guys remember this? A set, let's say a set contains a total of n elements. That is, the cardinality of a certain set is n. How many subsets could it possibly have? The total number of subsets that it could possibly have, what is that?
2 to the power.
Exactly, 2 to the power of n, right?
Yes,
Yes,
ma'am.
ma'am.
Yeah. How do we know that? By establishing a correspondence between the subsets of such a set and bit strings of the same length as the size of the set. Yeah. So if you remember this session, if you remember this from this previous session, in that case, we will utilize exactly that. You remember that this was in basics of counting. The purpose for proving things like this is so that we can use these concepts later on in proving other things. We will utilize exactly that concept to prove this identity. This identity here, which says that for any non-negative integer k and any non-negative integer n, then Cnk, where summation of all Cnk, where k is equal to 0 to n, k starts from 0 and increments by 1 and goes up to n, all Cnk, summation of all such Cnks will be equal to 2 to the power of n. We have to prove this identity. We will use that idea of subset to prove this identity. Now we know that 2 to the power of n is equal to the number of subsets of S, given that the set S has a size n. Okay, this is something we already know, right? If S is a set where the cardinality or the size of set is n, in that case, 2 to the power of n is equivalent to the total number of subsets of S. We know this already. We will use this in order to prove this thing. Now, think about the process of constructing a subset. How do we construct a subset? Can we not break down the task of constructing a subset into smaller tasks of constructing subsets of size 0, 1, 2, and so on until n?
Yes, ma'am.
Let's say the set S has in total n number of elements. First, we think about constructing all those subsets whose size is 0. How many ways are there to do that?
One
So
way.
you have that many subsets. Exactly, one way. Then we think about subsets whose size is 2. How many ways are there to create a subset? Basically, how many subsets can you have of size 2 of this set S, which has a size n?
NC2.
NC2, very good. Exactly, NC2. There are NC2 ways to do that. So there are NC2 subsets of this set which have the cardinality of 2. The subsets have a size of 2. Now, what if the size is 3? In that case, it's NC3, size 4, NC4, and so on. So the entire process of constructing all these subsets, by that I mean counting the subsets of this set, which has n elements, the set S, which has n elements, counting all possible subsets of this set. That process can be done in how many ways? It can be done by constructing subsets of size 0, then constructing subsets of size 1, then constructing subsets of size 2, constructing subsets of size 3, and so on
Summation of n share.
exactly
Yes,
until you construct the subset of size n. N is the highest limit, right? And will any of these subsets have anything will any of these subsets be common? If you have any subset which is common to some other subset, the subsets which are of size 0, will that subset be the same as any of the subsets which has size 1? No, the size is different, right? So first of all, we had a task where we had to count the total number of subsets of S, a set S whose size is n. Now, this task can be done by either creating subsets of S of size 0 or of size 1 or of size 2 or 3 or 4 and so on until the nth subsets where the size of those subsets is n, right? So this can be done in all of these ways, these sets of ways, okay? The set of ways where you have the subset of size 0, the set of ways where you have the subset of size 1, the set of ways where you have the subset of size 2, and so on until the last set, which contains the subsets of size n. And none of these sets of ways have anything in common with each other, like we established. None of the subsets will be the same as any of the other subsets, all right? They will all be unique and distinct. So by the sum rule, we can say that the total number of subsets of S is the summation of each of these subsets of size 0, size 1, size 2, and all that until n. So we can say that for k is equal to 0 to n, for k starting from 0, incrementing by 1 and going up to n, the total number of subsets of S can be represented by the summation of all the subsets of S with cardinality k, where k is equal to 0 to n. All right? K starts from 0, increments by 1, goes up till n, and the summation of all such subsets of S with cardinality k will give us the total number of subsets of S, right? Does it make sense? Is it true? What do you think? Is this correct so far? Is there any confusion?
Miss, I'm confused.
Okay, confused by what part? That the summation of subsets with k size, this part.
Yes, miss.
Okay. Total number of subsets. Do you understand this part? The first line, do you understand that? That total number of subsets of S, where S has the size n, is 2 to the power of n. Do you understand that part?
Yes, miss.
Okay. If you understand that part, then let's talk about the total number of subsets of S. To count the total number of subsets of S, we can think about how many ways are there to construct the subsets of S. The total number of ways to construct the subsets of S is the same as the total number of subsets of S, right? So this process of creating the subsets of the set S, this process can be broken down, or this process, I shouldn't use the term broken down, this process can be done either by creating a subset of size 0 or a subsets of size 1 or subsets of size 2 or subsets of size 3 and so on until n. Right? Think about it. Let's say I have a set S which has the elements 1, 2, 3, 4, 5. Okay. Now, first, I can create all the subsets which have cardinality 0. Right? All such subsets. What will that be? Cardinality 0 means what? S is empty, right? The subset of S is empty. Name this as 0. Okay. Another way is what? To construct all those subsets of S which have size 1. So S1 can either be 1 or 2 or 3 or 4, so on. You get the idea. Or we can construct subsets of size 2, in which case it would be what? Subsets of size 2. What
1,
would those?
2, 1,
Yes.
3, 1, 4,
Very
1,
good.
5, 1, 6.
1,
So
2, 1, 3. Yeah.
it will be like n into n minus 1 divided by 2, like arrangements for like 2 elements. Right.
Yeah. So like that. Okay. So this is what I'm saying. A set or subset jodi banate chai, either I can construct subsets of size 0 or I can construct subsets of size 1 or subsets of size 2 or subsets of size 3 or subsets of size 4, so on until what?
Until the total number of elements, until we take all the elements, like
What is
1, 2,
that?
3, 4, 5, 6. It's like S6.
Exactly. All the subsets of size 6. How many such subsets will be there? Only 1. That's not important, but you get the idea that so in order to construct the subsets of this set, you could either construct it by creating subsets of size 0 or size 1 or size 2, size 3, 4, 5, and so on until 6. Okay. So do you understand this part? Is this clear with everyone?
Yes, ma'am.
Okay. If this is clear, then it's the same thing here. See, here we have a set of size n. So can we not say that, let's say here we have until n, any positive integer n. You have n elements here. In that case, could you not say that this is what it is? Could you not say that the subsets of this set can be created, that is this equivalent to S aquí. The subsets of this set can be created by either constructing subsets of size 0, subsets of size 1, subsets of size 2, 3, 4, 5, 6, and so on until subsets of size what? N. And the total number of subsets of the set S, all right? The total number of subsets of the set S. The set S would be what? Equivalent to what? The total number?
N. Oh, so, S1 will be n. Then S2 will
Basically,
be...
the summation of all the
Oh,
subsets.
to the power n.
Right. Yeah, it's 2 to the power of n. Yeah, we don't know that. But the total number of subsets of size 0, the total number of subsets of size 1, that is S0 to যতগুলা subset থাকবে. S1, A liste, all the subsets of size 1, or the total count of the subsets of size 2, the total count of the subsets of size 3, and so on until n, the total count of the subsets of size n. Right? যে 0 সাইজের যতগুলো সাবসেট আছে, count that, plus 1 সাইজের যতগুলো সাবসেট আছে, count that, plus 2 সাইজের যতগুলো সাবসেট আছে, count that, plus 3 সাইজের যতগুলো সাবসেট আছে, count that, and so on until the total number of elements in the set, the original set, the parent set, all right, the total number, until the count of the total number of subsets of size n. Okay, ওগুলো সব sum up করলে, if you sum all of them up, you will get the total number of subsets of the set S. Will you not? Is this clear?
Yes, ma'am.
Okay. So in that case, that is exactly what we're doing here. Yeah. So we have the total number of subsets of the set S with size n, which is equivalent to the power of n. We know that from previous sessions. And these subsets, the total number of subsets of S, also can be represented in this way. Summation of the total number of subsets of S with cardinality k, where k is equal to 0 to n. That is what we have here, right? Total number, summation of all the total number of subsets of S with cardinality k. Summation, তাই না? Total number of sets of cardinality k when k is equal to 0. Total number of sets of cardinality k when k is equal to 1, then k is equal to 2, then k is equal to 3, 4, 5, and so on until k is equal to n. So the summation of the total number of subsets of S with cardinality k where k is equal to 0 to n. Just this is represented in this way. Any confusions left? Is this clear to everyone?
Yes, miss.
Okay. So in that case, now tell me, how many ways? What is the count? What is the count of subsets of size 1, 2, 0, all of these things? Think about it. When you're selecting, sorry?
NC1 for subsets like with cardinality 1.
Yes,
and
correct.
S2 with
That's
cardinality-
correct.
Yeah. So
Yes.
NC. So we sum them up. So yeah.
NCK basically, right? So for subsets of size 0, what are you doing? You are choosing 0 elements from a choice of n elements, right? How many ways are there to do that? NC0.
One way.
Only one way. NC0, which is only one way. Subsets of size 1. What does it mean? Subsetter size 1 মানে কি? Subset কয়টা element থাকবে?
একটা element.
একটা element. How many options do we have in the parent set?
N elements.
N options. So So from n elements, you have to choose one element. How many ways are there to do that, to choose the element? In set, remember, duplication doesn't count and repetition doesn't. NC1 ways. NC1 ways to do that. When the size is 2, what are you doing? The size of the subsets of size 2, the subset of size 2 will have 2 elements. So you have to choose 2 elements from a choice of how many options?
So from n options.
From a choice of n options. Parent set, remember, there are n elements, and in the subsets, for the subsets of size 2, every time you're selecting 2 elements from a choice of n options. How many ways are there to do this? NC2 ways. Ar jotogulo way ache totogulo subset, right? The total number of ways to construct subsets of size 2 of this set S, which contains n elements, is NC2 ways. And that's the total number of subsets that we have, all right? And so on until Sn, where there are n ways to do this. Basically, if you think about the number k, for k starting from 0 and going up until n, there are nck ways to do this. There are nck ways to construct subset of size k starting from 0 to n, all right? So each of these total number of subsets of S with cardinality k, all right, where k starts from 0 and goes until n. K jokon 0, the total count of the subsets is NC0. K jokon 1, the total count of the subsets is NC1. K jokon 2, total count of subset is NC2, and so on until n, where the total count of subset is NCn. So can we not say that the total count of the subset is NCk, where k is equal to 0 to n? Guys, can we not say this?
Yes, ma'am.
Does this make sense to everyone? I mean, anybody here who's confused or doesn't understand any of the parts? Okay. All right. So in that case, we have that QED. So right hand side, we started from the right hand side and proved the left hand side from that. All right. So there you go, QED. Okay. So let's take a quick break for everyone who needs to pray for go for the Maghrib prayers. All right. So let's just come back here after 10 minutes or so. All right. So it's 5:24 right now. Let's join back at 5:35. Okay. Is that okay, guys?
Yes, ma'am.
Yes, ma'am.
Okay, ma'am.
All right. Would that be enough, or do you need more time? All right then. Okay. So I'll see you guys back here at 5:35.